Hello YouTube traveler, welcome. In the past video we learned about conditional processing, which allowed us to use conditions in order to execute actions. Today we unlock the second superpower every program needs, iteration, telling the computer keep doing this until I say stop. And in short, iterative processing is achieved with something called loops, which are a special kind of instruction that repeats a piece of code until a certain condition becomes false. There are 4 kinds of loops: for each, do, and do while, and we'll cover them all in this video. The most simple of them all is the while loop, which looks like this. If I run it, let's break it down. We declared an int variable and initialize it to 0. Then we wrote the while loop, which as you can see is formed by the while keyword, a boolean condition between parentheses, and a block of code. All this is very similar to an if. In fact, it's exactly similar, with the only difference of the while keyword instead of the if one. And it actually works almost the same. We need between parentheses something that will always produce a boolean condition, either true or false. And when that condition is true, what follows in the block of code between the opening and the closing curly brackets will be executed. What is different is that in the case of the if, when the block of code finishes executing, the execution jumps to whatever follows after that block. In the case of the while loop, when the codes inside the block of code finish executing, the condition is evaluated again. If it's true, the block of code is executed again. Then the condition is reevaluated, and so on and so on. So the block of code is executed repeatedly until the condition between parentheses is evaluated as false. Only then the execution will jump to whatever follows after the block of code of the loop. So it literally reads, while this condition is true, keep executing this block of code. You can also see that the condition of the loop is to check if number is less than 10. Well, since we initialized it as 0, that condition is true, and it would remain forever and ever true unless we change the value of that variable. Therefore, in the block of the loop, we also increment it, meaning we add 1 to its own value each time the loop cycles. So on the first iteration, number is 0, which is less than 10, the condition is true, the block of the loop is executed. But here we increment the value. So number is now 1, the condition is reevaluated, 1 is less than 10, which is true, the block of the loop is executed again. Number is 2, condition is evaluated, and so on and so forth. The point is, at some point, number will be 9, meaning when we increment it, it will become 10. 10 is not less than 10. Therefore, the block of the loop will no longer be executed, and the codes that follow after it will be executed. So effectively, we have a way to actually count from 0 to 9 automatically. How cool is that? Obviously, we can also count down by declaring and initializing the number as 10, modifying the condition to check if it's greater than 0, and decrementing instead of incrementing. The next kind of loop is the do while one. It looks like this. Simply, it works precisely as the while loop with a single difference. The while loop first checks the condition, and if that returned true, it executed the codes. The do while loop will first execute the codes and then check the condition to see if it needs to execute them again. So the difference is that the do while loop will execute the codes at least once, even if that condition is false. Next loop we cover is the for each one. Unfortunately, it's based on stuff we haven't learned yet, but trust me, it's really easy. Let's have these codes. I initialized what's called an array of ints, and we will learn about it in a future lesson. But for now, just know that it's a collection of multiple values, multiple ints, packed in a single variable instead of a single one. So we have multiple ints, and then we use a for each to iterate through them. And the way it does it is to take the value of the first element, put it in this variable right here, and then executes the code where that variable can be used. then take the value of the second element, put it in the variable, execute the codes, and so on until all the elements in the collection are used. So therefore, the for each is best suited when you have a collection of data, like the list of products in some database table, and you want to do something with all the elements indiscriminately, like printing their price maybe. The last kind of loop we will cover today is also the most complex, the for loop, which is kind of like the freaking Swiss Army knife of loops, and it looks like this. There are three sections to the for loop. The first one is where we declare and initialize an int variable, which will keep track of how many times we repeated or cycled the execution, and we call it counter, but we could just as well call it index or just I, as many programmers do actually. Then we have a section where we check a Boolean condition, just like we did with the while loop. This one will determine if the block of the code of the loop will be executed or not. And the last section is where we increment our counter variable, just like we did with the while loop, except there we were doing it in the block of the code of the loop. Here it has a dedicated section as part of the syntax of the for loop. And finally we have the block of code which will be executed when the condition is evaluated as true. So how does it work? Well, we declare the counter variable as 0. Then we check if its value is less than 10, and because that's true, the block of code is executed. Then the execution jumps to the part where the counter variable is incremented, so its value is now 1. Then it goes to the condition check again, not the declaration part, which runs only once when the loop starts. If it didn't, the counter variable would have its value reset to 0 each cycle, even if we kept incrementing it. So, condition check, 1 is less than 10, yes. The block of code is executed, the counter is incremented, 2. Condition check, 2 is less than 10, yes, and so on, until counter would have its value as 9, where incrementing it would make it 10, which is not less than 10, condition would be false, and the block of code would not be executed, the execution would continue with whatever follows after, just like it did in the case of the while loop. And like in the case of the while loop, we can also count down, not necessarily up. So we could declare counter as 10, check if its value is greater than 0, and decrement. And speaking of incrementation and decrementation, we can also do it by whatever value, not necessarily 1. So we could have this. Where we increment in steps of 10. Or we could have any other mathematical operation, not necessarily addition. Where we multiply by 2 each step. You should also note that the counter variable is only visible inside the block of the loop, so this would not work. Because again, counter is declared as part of the loop, so it's only visible inside this block. If you wanted to make it visible outside, you would have to do something like this. So I declared an int variable like we did in previous lessons. Then I used the for loop where I used that variable and I didn't declare a new one in the declaration part, so we don't have a dedicated control variable. We use the one dedicated outside. However, I am still obligated to put the semicolon for that section, so keep in mind that. And it works. The declaration is not the only part that you can omit in a for loop. You could declare the control variable outside the loop and increment it inside the loop's body, not necessarily in the third section, like this. And it would work just the same. But again, you need to put the semicolon for that section even if it's empty. Heck, you can even declare a for loop without any parameters like this. And this would be an infinite loop because there is no condition to end it. So practically it would print this message on the screen until the end of times or until you close it. You can even declare multiple variables, multiple control variables for a for loop like this. But this is rarely used. These were all the types of loops, but we are not done yet. There are two more operators we need to learn about in relation to loops: break and continue. Let's look at it. If you remember, a while loop will continue to run as long as its condition is evaluated as true. So because we use the true keyword, that will always be true. Effectively, we get an infinite loop. But if we look inside the loop's body, you can see that we increment I on each iteration. And then we use an if condition to check if its value is greater than 10. If it is, we use the break keyword to immediately break out of the loop, to immediately end it and continue with whatever follows after its body. So, this is the purpose of the break operator, to abort the loop whenever you want. On the other hand, the other operator, continue, is used like this. Again, we declare and initialize I as 0. Then we have a normal while loop where we check if its value is less than 10, and inside it we increment it. So basically a loop where we count from 0 to 10 like we've seen before. But we also have an if-else check where if the remainder of our integer being divided by 2 is not 0, so if it's odd, then we use the continue operator to skip the current loop's cycle. If it is 0, so the number is even, we print it on the console. So unlike break, which ended the loop entirely, continue will just skip the current cycle and jump to the next condition check. So it's simple. Continue to skip the current loop cycle, break to end it entirely. The last thing we need to discuss about loops is actually a warning. Nested loops. Take a look at this. As you can see, I declared a for loop with a variable called x and made it iterate twice. Then inside it, I declare another for loop with a variable called y and make it iterate 10 times. But if you look at the output, you can see that yes, x iterated twice like we told it to, but y iterated 20 times. Why? Because the inner loop has to run all its cycles for each cycle of the outer loop. So be very careful about nested loops in regards to performance. It can be nailed down pretty easily with loops inside loops inside loops. That's all I had for you people, and it's getting pretty exciting, isn't it? Because now we can do stuff conditionally and repeatedly. In the next clip, we will start learning about collections, particularly that array thing I was discussing when I was mentioning the Foreach loop. So don't forget to subscribe so you don't miss that one. If this helped you in any way, please hit the like button as a thank you for the time and effort spent doing this. Thanks for watching, and I'll see you in the next tech frame.